It will take 3 minutes break up, right? Okay, I hope everyone at home also ready already. So we look at the chapter 4. So basically what you have learned in chapter 3 probability and all the few addition rule, multiplication rule, addition probability, and then we apply into tree diagram and table. Okay, so I hope you all practice more. Okay, the next one will be chapter 4. This is also probability, but we talk here about distribution. Now, what's the main distribution? What's the difference between probability and probability distribution? Now, for distributions, we want to study we call it characteristics of the probability. So in chapter 3, we concentrate a lot on calculate probability, right, of certain event. So in this case, we don't calculate probability. We calculate the distributions. There are two types of distributions in this subject. One is called binomial. I'm sure you all heard this word before, binomial. And the other one is called normal, the one that I draw this few times. This is your normal term. Okay, so here chapter 4, we come back to this normal probability again. Right now, so let's start now. Okay, let me explain to you what's called distributions. Frequency distribution gives an analysis of the number of times each particular value occurs in a set of items. Probability distribution simply replaces the actual numbers, or we call it frequency, or we call it proportions of the total. So, for example, let's look at one class with 50 students, and then here the marks are the test statistics marks are given out of these 50. We take, let's say, 10 or marks out of 10. So the number of students here will represent how many students get that particular marks. We call it frequency. Remember chapter 1 and 2 talk about frequency. It's the number, okay? And then here we have one column called proportion, or we call it probability distribution. This is the one that we have to focus. Why? Because at the end the total is 1. So if you ask me what is probability distribution, I will tell you it will be very long, right? Now below this normal curve, all these are probability. You see the table very soon to this. So we don't care how long is the left, how long is the right table. As long as from here, one end to one end, the total must equal to 1. That's why the probability cannot be more than 1. Remember last week we learned that? So that is distribution means. Now you see, let's say 0 marks, no student get. 1 mark, let's say no student get. Let's say 5 marks, you have 10 student gets. Then let's say 9 marks, you have 2 student get, and so on. So the total here 50 lah, 50 students, but you will give the marks out of 10 only. So how you calculate this probability distribution? Take the frequency divided by 50, right, times 100%. If you want to get percent, but here we just leave it in proportion. So you just take this number divided by 50, kind of 1 divided by 50, 2 divided by 50, 4 divided by 50, and so on. So important thing here, the total proportion must equal to 1 or 100%. Correct or not? So now we know reverse probability distribution. Very simple. It's just the frequency divided by the total only. Okay. Now a probability distribution can be discrete or can be continuous. 2 types: discrete or continuous. Chapter 1, you remember what is discrete and what is continuous? Discrete means what? Integer, cannot be point bomb, such as what? Table, chair, cars, all these are discrete. So whenever your variable, I highlight this word, RV. RV means stand for random variable. Variable means like what? Table, chair, cars, right? These are variable. If it's a discrete round number, you must use what? Binomial. So for this chapter, we learn 2, binomial and normal. Actually, there's one more called Poisson. Poisson, you see these scissors are. I don't know why the lecturer use scissors. To inform you, we already cut this. We don't study this in this subject. Alright? So we only study binomial. Poisson actually important, I mentioned that, but at the end, we still don't want to put this into your subject here. So we only study binomial. Okay? Only for discrete. Now, if you have a random variable which is continuous, remember, continuous data, those with the point bomb, like the length, the height, the weight, right? All got the point bomb. Then we are going to use what? Normal distribution. This one. Okay. So your chapter 4 very easy, two distribution, binomial and normal. Okay, so let me start with binomial now. Okay, how we know that is binomial? How we know the question is asking about binomial or normal? If the question never mentioned binomial or normal, how we know? So we have to look at four conditions here. I'm not asking you to look at four conditions. Actually, there's one or two conditions that you can spot. The first one, out of the n identical trials, if the experiment is repeated n times under the same condition. So the first condition, when you want to talk about binomial distribution, the event must be repeated under the same condition. Let's say you throw a coin. Everybody, you throw a coin. Everybody throw a coin. Now, when you throw a coin in the room, let's say go back to your room at home, you throw the coin in your room. So you throw 1 time, 2 times, 10 times, 100 times, I don't care how many times you throw, you must throw inside your room under the same condition. You cannot go to the kitchen and throw. You cannot go to the bathroom and throw. You must throw in the room. Why you must say same condition? If you throw in the toilet and you throw in the canteen, do you think it's the same condition? No. Why? Not fair. Which we call it what? Bias. You don't know what's called bias, right? In Mandarin, what do you call? Tidak adil. So you must repeat the experiment in this same condition. You cannot change phase one now, okay? Or you cannot change your conditions. First thing. Second thing, for binomial experiment now, has only two outcomes. Only two outcomes. Just now I asked you, in exam, how do you know this binomial or not binomial? How do you check? You check the two outcomes. What is that? We call it, in statistics, we call it success or failure. P for pass, F for fail. Only two outcomes. Now, what other example where you have two outcomes? Good or bad? Defective. Remember just now we talked about D and D bar, non-defective. So all these are either A or B, right? Good or bad. Boy or girl. Gain or loss. Win or lose. Beautiful or not beautiful. Tall or short. Fat or thin. Dark or bright. Either yes or no. So only two outcomes. If you have any event where there are more than two outcomes, that's not binomial already. So we call that, in statistics, we call that the two outcomes for any independent trial. Now you see the word here we use independent. How we use independent? No condition. Remember chapter 3, we have independent, no condition one. One event does not affect the other event. So for binomial, very important, no condition, it must be independent. That's why I say, in the first condition must be what? Same condition. Because we don't want other factors affect the experiment. You must go, you throw 100 times in the bedroom, you must throw in the bedroom. In the toilet, You cannot go to canteen, then toilet, then here and there, cannot. Because of the conditions are affected. So for binomial, it must be independent. And just now we talked about two outcomes, success or failure. So usually in statistics, when you do your tutorial question, classic question, usually we define the probability of success as P. We use the symbol P. Most textbook, in fact, in the worldwide textbook, they always use P and failure probability as Q. These are the two symbols we use. We don't use other symbols. We use P and Q. This is the standard practice. Now not only Malaysia, but it's a world textbook. So as I said, in terms of probability distribution, I don't care how many frequency you have, right? I don't care how many proportion you have. The total must equal to 1. So even though I have success and failure only 2 outcomes, the P plus Q still equal to 1. Remember, 60% boys means 40% girl. Together must equal to 1. Remember the tree diagram? Whether 2 branches or 3 branches, the total must equal to 1 for each branches. That is for sure. So for binomial, even easier, you only have 2 outcomes. So every time when you do equation, you only see P and Q. If P is what? If P is 0.7, the Q must be 0.3 only. That's all. There's no way for you to make this statement unless you count only or whatever. Okay. Now the condition number 4, independence, as I mentioned, outcome of one trial does not affect the outcome of another trial, which is no condition there. Okay, now this is how we do when we answer the question, we follow the format here. First thing, we have to let X. So this is your random variable, as I mentioned before. Okay, usually we let X equal to what? The number of successes in the n trials. Then X is having binomial with parameter n and p, denoted by this symbol. So after we write this definition, we must tell people what's the X now. Okay, if you don't write this, then suppose that person don't know what are you calculating. So if you show people, you define the X as what? Number of successes out of the trials. Okay, we see the example later. Then people will know this X random variable equal to what. And then second step, you must write this X distribute. You see this symbol? This symbol means distribute as B. Stand for what? Binomial. Some textbook they use BIN, short form. Some textbook they use B. It's the same. And then you must show what is your n, number of trials. Okay, you throw coins 10 times or 20 times, then you write n here. And then P is what? Remember P? Success, probability. Okay? And then the third one, we quote the formula. The probability to get exactly X success out of the n trials. Let's say you throw, example, let's say you throw a coin 100 times. 100 times. So what's your n here? 100. You throw the same coin, same experiment, you repeat, right? Or in the toilet, you throw 100 times. Or 20. So n 100. Now, to get the X success, let's say you want to get probability to get 20 times or 100 times, or you want to get 20 times 8. Or 100 times, you repeat experiment, you want to get 20 times 8. So this will go to what? X. So you write as what? X equal to 20. That's why you must define your X. Okay, get how many hit out of 100 times you throw the coin. So you define the X really, then you write the distribution, and then you continue the experiment. So you know X equal to 20, you want to get 20 hit. This is your formula. K stands for probability. The big X here refer to what? The event that you define here. Get how many hit out of 100 times you throw, equal to the small x. This x equal to 20. If you want to get 30 times, then x equal to 50. If you want to get 50 times, x equal to 50. Equal to NCX. How many of you have seen this formula before? Last time you learned in your MS. Some of you, right? Those of you who take MS1, you should be able to recall this. Even though the formula symbol is slightly different, but it's still the same one actually. Yeah. For those of you who never learn MS, who never see this formula before, don't worry. This formula is very easy. No need to memorize, you'll be given. But for your practice, you just make sure you write down. Okay, a few times you will be able to remember. As I mentioned, sleep also you can remember. Take your lunch, dinner also you can remember. Because every time you write down, automatically calculate or log in already. Okay? So NCX. Now this is the formula that you can get it from your calculator. Okay, times the P, success probability for X, times the Q. Now 1 minus P here, you know what's 1 minus P? From this P plus Q equal to 1, remember? So if I want to find Q, I can take 1 minus P naught square naught. Right? So some textbook they write Q. Some textbook they write 1 minus P, up to you. If you know P is 60%, 0.6, Q here will be 0.4. If this is 0.2, P, the Q will be 0.8. Okay? Power of n minus x, where the x is starting from 0 to the n. Total number of trials, P is the success probability, x is the how many success you want out of the n trials. Yeah, now, those of you who don't know how to calculate this, can you take out calculator? For those of you who already know this, you can just try also. Now, everyone have calculator? Those at home, do you bring do you have calculator at home? Okay, now let's do some practice. Now you see your calculator got the button NCX, right? Anyone don't find that? The yellow color one, right? So let's do some exercise. Okay, now when you have this formula, when you want to calculate the probability, right? Let's say M is 10, C, let's say the X is 5. What do you get? Press the shift button. Is it shift button? 10 C5. So shift NCR. So you press 10, press the NCR, press 5. You get 2 by 2, right? Anyone look at home? How about you? Okay, all right. Another example, 16C5, or 16C8. 60 is the N, so you press N16 shift NCR, you press H, you get here 12870. There's a formula to calculate the NCR, but this one is under mathematics, so we won't spend our time here. Everyone make sure you know how to press that. Okay, all right. So we do two example after this using the full formula. Okay, now before we do the formula and example, for binomial distributions, remember the mean variance standard deviation we learned in chapter 2A, right? Mean for population. Remember this symbol? Chapter 2A, we have group data and raw data, right? Remember next week is your quiz. So this do your revision. So for binomial, the mean, this is what? Population or sample? Hello? This symbol is for mean population or sample population? Next week is your quiz really. Population or sample? Do you know what's population and sample? What's the difference? Big group and small group. So this is mean, right? Population. I hope my prediction is correct. You all want to wait until last minute only do the revision, is it? Sample mean is like this. X bar. Still only, right? Haven't done revision. Total X divided by N for raw data. Right, for group data, you must have a FX, the frequency. So this is sample, the smaller one, population mean. I told you alright, you must remember the person face and the person name. You cannot remember face and you forget about the name one, or you know the name but you don't remember the face. Cannot, no. You must remember the name and the face. So the formula is very simple. Take the n times the p. Simple, right? Want to memorize also can. Variance, do you remember chapter 2a? What's variance? Dispersion, right? How far the mean from the area? Remember I mentioned this. You have the data. This is your mean now, population. Actually, binomial and normal is related one. For big group, they are actually under normal. So this is your mean population. Remember the meter value. So x1 data, x2 data, all the difference to the mean is called dispersion. Remember within dispersion, the spread, the variability. So this is your variance. This is called what? Sigma. Remember, this is what? Population standard deviation. If it's sample, we use what? S. Remember, this is population variance. We talk about population mean. So for variance, show population variance. If it's population, so if a sample standard deviation, we use what? S. Remember? Still can't remember. Standard deviation is the square root of variance. Remember? Square root of variance. So we square root, no more square here. So we take the square root of NPQ. NP times Q. 1 minus P is Q, right? It's the same one. Okay. Alright. Let's look at an example using the formula. Now, I start with this point. After that, I will go to more example using the full formula. I hope we can finish it in this time. So the first one, we take a coin. We want to know the number of hits showing the face up on the three toes of the coin. So the results, possible results are 0 hit, 1 hit, 2 hits, and 3 hits. Or it could be no hit. No hit means 0 hit. So find the probability for each number of hits. If the x denotes the number of hits, find the mean and the standard deviation of x. So you define the x as well. Remember I mentioned that you have to define let the x is what? How many times you get hit up. So you define the x. So this is the answer. Number of hits showing up on 3 toes of the coin. Many people don't like this. So I have to warn you, if the marking scheme gives half marks for this, and any of us don't like this definition, you don't get the half mark. If the marking scheme gives 1 mark, then you don't get 1 mark. Compared to those who write, they get 1 mark. So to be fair, those who don't write, you don't get 1 mark. Must be fair, right? Those who write get 1 mark, those who don't write don't get 1 mark. Simple as that. This one also. Distribution, binomial, we throw 3 times, right? So n is 3. Yp is 0.5. You throw a coin, you get head or tail, right? The chances to get hit is half, tail also 0.5. Simple as that. So this is the formula, remember? P x equal to number of head. So 0 head. So 3 n is 3. Put all the values inside 3c0. Then your p or x, right? So 0.5 or 0. Then the q, 1 minus p is q. If 0.5, q also 1 minus 0.5 is 0.5, power of n minus x. So 3 minus 0 is power 3. So calculator. The probability to get no hit out of 3 times you throw the coin is 0.125. That is what it means. Okay, how about if you get 1 hit? So 3c1, see? 3c1 calculator. 3c1 is 3, right? That you times the p, 0.5, power of 1 here, power x, n times q, 1 minus p, also 0.5 power of n minus x. So 3 minus 1 is power 2. Okay, be sure you know how to press calculator, times carefully, 0.375. That means that probably you get 1 hit out of 3 times of the throw, the coin is 0.375. So can you try this? 2 hits and 3 hits. Total must equal to what? 1. So this table shows the probability distributions of throwing 3 times the coin, and this is the each probability we can get. Okay, I know. Total must equal to 1. So everybody familiar with the formula? Okay. Now, let's say I want to find the mean now. The question asks you to find the mean, right? And the standard deviation. So the mean is what? N times P. Now, even though we have 3 trials, 3 times you throw a coin, we still take it as a population. Remember, I mentioned that unless the question says sample, selected, some, remember chapter 2a, I mentioned the keyword there, then you use the sample without population. So n times p. Okay. Population standard deviation. NDQ, right? Standard deviation, you use square root. If varies, you just square it. It's the same, right? So NP times Q, 3 times 0.5 times 0.5, square root 0.75 is 2.860. Yeah. You want to find the variance, you just square this up. Okay, now let's look at 2 more examples just before we end. The probability that a college student will graduate is 1.4. So what is our random variable here? Are we student graduate? Am I right? So what is our success probability? P is what, 0.4. We are talking about student graduate, and Q is what? Student cannot graduate. Remember two outcome? Yes or no, boy or girl. So we are talking about graduate and non-graduate. So that means the Q is what? Non-graduate 0.6. Okay, now out of 5 students, so what's your N? 5 students are. So we take 5 students as an experiment. Find the probability no one graduate, 1 graduate, at least 1 graduate. At least 1 means what? 1 student, 2, 3, 4. At least means minimum 1 of them. And all will graduate. Okay, ready? So define the X number of students are graduate out of 5. Define this 1 mark. Second step, show the distribution of X. Remember this one? Okay, then third step, write down the formula. So 5C0 P power X, X is 0. Okay, 0.5 power X times Q 0.6 power 5 minus X, okay, N minus X. So when no student graduate, 5C0 P power 0, Q power of N minus X, 5 minus 0 is 5. The calculator, you get this? 1 student graduate, 5C1, P power 1 times Q power 4. 5 minus 1 is 4. The calculator, you get 0.2592. Okay, now, I would like to spend some time to discuss with you what's the meaning at least 1, minimum 1 student graduate. So it could be what? 1 student, 2 student, 3, 4, and all graduate. Cannot be 0. 0 means no student graduate. So minimum 1. That means you have to start from 1, 2, 3 up to 5. You have to add it up 1 by 1. So are we going to repeat 5 times here? Now you see, we call it shortcut formula. What we call it shortcut formula? More than 1 means more equal. So more equal means at least 1. And this means you start from 1. That's why there's an equal 1 here. So you start probability from 1 student graduate, you have to calculate like this, plus 2 student graduate, plus 3 student graduate, plus 4 student graduate. Every time you put into the formula, calculate, and the last one, 5 student graduate. Those of you who are free later, you can add it up. Calculate one by one, add it up. Is this what you want? If I have 10 students, are you going to calculate 10 students, 20 students? Crazy, right? You waste your time now. By the time you finish calculating, type already. So what's the shortcut formula? So I use this shortcut formula. Now, I have how many students? 5 students. Let's say you look at your box here. I have 5 students. So no student graduate, 1 student graduate, 2, 3, 4, and all graduate. So when I added up all these, the total probability must equal to what? Remember? From no student graduate, 0, 1, 2, 3, 4, 5, added up all together must equal to 1. So if you want to calculate from 1, 2, 3, 4, 5, you want to know how many here, you can do like this one way. If you think you are having a lot of time to do this slowly, or the shortcut is what? You take 1, because the total is 1, you minus which one? The probability less than 1. Less than 1, which is no student graduate, which is what? 0. So you take 1, minus this out, the probability of 0, you see? 1 minus probability of no student graduate. So you calculate only one time, x0, put inside the formula. You only calculate one time, then you take 1 minus this. You try again, you see? When x is 0, you get this one, 0.0778. So you take 1 minus this. The balance is where? This is a circle one. If you don't believe, later you see somewhere and then you calculate all this 1 by 1 total. Is it equal to 0.9222? So I call this shortcut formula. Whenever you do a tutorial later on, or passing questions, if the question says at least 1, or you have 5 students, okay, if you have 20 students, are you going to do from 1 to 15? 1 whole list. What's the easiest way? Take 1 minus whatever you don't want. Whatever you don't want is 0. The balance will be from 1 to 5 student graduate. I'm saying this because when you do your other question, right, it's not necessarily 1 minus the 0. You have to read the question, see which one you don't want, take the total 1 minus 10 out. The balance will be, the remaining is the probability that you want. Understand? Okay, you try to see. Okay, the day here, the last question is what? All will graduate. Means what? X equal to 5 out. So you put into your formula 5C5, 0.4 power 5, 0.6 power 0, plus 5 minus 5 is 0. So you try and see, calculator. Okay, before we stop, let's look at one more last example here. A new car salesperson, right, knows the past experience. From past experience, she make a sale to about 20%. What that means? She can sell car to about 20%. So the success probability to sell a car is 0.2. So what's your Q? Can sell a car 0.2, cannot sell a car 0.0. Success and failure. So find the probability that in 5 or 5 sales, 5 customers. 5 customers. What's the probability? Exactly 3 at most. What's the meaning at most? Maximum 3%. Maximum 3% means you have to calculate what? No customer by 1 customer by 2 customer by, and maximum 3 customer by. This at most. See, at least one customer, minimum one. Fewer than 3. Fewer means less than 3. More than 3. Okay, more than 3. So make sure you all understand the word fewer, more than, at least, and most. Make sure you don't confuse yourself. Okay, now this is the definition. Let X is the number of sales in out of 5 times. This is a binomial 5 and P 0.2. This is a formula, right? Okay. So the first one, can we calculate this one? I give you all 3 minutes to calculate exactly 3. At most 1 customer. Sorry, 1 customer. I read only here. We shouldn't be 3 here. At most means maximum 1. At most 1 customer means 0 and 1, because no customer buy also consider, because they say at most 1. So maximum, at most means maximum 1 customer. So that means you have to find probability no customer buy plus 1 customer to buy the car. So PX0 and PX1 total up. This is your answer. Can you try now before we stop? I want you to understand the word at most. What's at least? At least means minimum 1. Like just now, you want to calculate what? Minimum 1 means you start from 1 customer buy, 2 customer buy, 3 customer buy, 4, and 5. Are you going to find 1 by 1? Yes, you can. But you want to use shortcut? Okay, you take 1 minus Px equal to 0. No customer buy. No? Okay, D, fewer than. Fewer than means you, we write X less than 3. Fewer means less than 3 customers. So less than 3, less than 3 means what? How many? Start from where? Less than 3 means no customer buy. So you must find PX0, 1 customer buy, and 2 customer buy, right? Less than 3. So the 3 cannot, only 0, 1, and 2 customer buy. Okay, can you try to get this answer? 0.9421. And more than 3. More than 3 means X more than 3. Now, how many customer total? 5, right? So more than 3, you can find 4 customer and 5 customer. 4 and 5. Actually, not bad, you only calculate 2. Calculate 2, so you can find 4 and 5, add it up. If you compare to part C, at least 1. At least 1 means you have to find 1, 2, 3, 4, 5, right? If you find it too many, then you use shortcut. So the word shortcut means you take 1 minus the one that you don't want, right? Probability. But if you find that only 2 or more than 3 customers, 4 and 5, then you still can calculate 4 and 5 probability, add it up. So when you do a tutorial, you find that you need to calculate many, then you use a shortcut. If you don't mind to use long way, go ahead. If you want to use shortcut, make sure you know 1 minus which one to get the same remaining probability. Okay? Then find the mean and the standard deviation. Mean is by NP. Standard deviation is square root of NPQ. This is the answer. Okay? Alright, so you see the word here? Now, can you all see this table? At least is marked. At least means minimum. So you see the symbol we use, X more than equal. At most means maximum. So we say X less than equal. Cannot be more than really maximum. Lesser than or fewer than, we use less than. Exceed or more than, we use more than. Not more than, we use X less than. Now you see not more than and at most they are having the same symbol, less equal. Not less than means you write more or equal. So you can see that the symbol not less than and the symbol for at least is the same, got equal sign there. Okay, so not less than means can be equal, not more than also. So take note of all the inequalities, we call it inequalities. So this is very important because you want to know from which probability up until which probability. Yeah. All right, so I will stop here. Any other question from anyone? I don't have already. So that's all. So I will post the video for this. And so for those of you who haven't tried the dry run test, please quickly do it and make sure you know what to do because next Saturday, don't forget. Any question you can inform your tutors. All right, that's all. Stay safe. See you all next week. Okay, bye everyone.
Bye, sir.
Okay, see you all next week.